Now our inverse matrix is, as we saw before, 5 20-seconds, 3 20-seconds, 2 11ths, negative 1 11th. If we multiply that by our original matrix, now we should really be multiplying with the inverse matrix on the left-hand side to mimic what happens. But as it turns out, matrix multiplication does depend on the order in which you multiply the matrices. It's not commutative. But when you multiply a matrix by the inverse matrix, it doesn't make any difference in what order you multiply them in this case and in certain other cases. Okay, well, your matrix 2, 3, 4, negative 5 multiplied by your inverse matrix. What do you get? 2 times 5 20-seconds plus 3 times 3 times 2 11ths, sorry. 2 times 5 20-seconds plus 3 times 2 11ths. And then 2 times 3 20-seconds and 3 times negative 1 11th. And then the second row, 4 times 5 20-seconds, negative 5 times 2 11ths, and then 4 times 3 20-seconds, and negative 5 times negative 1 11th. Okay, make sure all those are in the right places. In the first row, you're always multiplying by the row 2, 3, so your first row should contain the 2, 3 here and here. Second row, you should have the 4, negative 5, and the 4, negative 5. In the first column, it's always the 5 20-seconds and the 2 20-seconds, so there they are, and there they are. And for the second column, it's 3 20-seconds, negative 1 11th, 3 20-seconds, negative 1 11th. Just making sure everything is aligned. We can then do the arithmetic. 2 times 5 is 10, 3 times 2 is 6. Well, we don't have a common denominator. We get 6 11ths, which is 12 20-seconds added to the 10 20-seconds here. 10 and 12 gives us 22. So we have 22 20-seconds. That's just 1. Here, this and this are equal and opposite. 2 times 3 20-seconds, we can divide the 2 into the 22. We get 3 11ths, and here we get negative 3 11ths. They clearly add up to 0. Then, excuse me, 4 times 5 20-seconds is 20 20-seconds. Negative 5 times 2 is negative 10. That's negative 10 11ths, which is negative 20 20-seconds. So we get 20 over 22 minus 20 over 22 gives us 0 as advertised. And then here, 4 times 3 is 12. We have 12 20-seconds, and we have 5 11ths. 5 11ths is 10 over 22. Add that to 12 over 22. We get 22 over 22, which is 1. Okay. So, when we multiply the matrix by the inverse, we get the identity matrix. Now, isn't that similar to the whole role of an inverse when we're adding or multiplying? If we add the inverse of a number to itself, we get 0. The additive inverse is the number you add to a number to get 0. So it's like negative 5 and 5 gives you 0. If you multiply two numbers, then the inverse for multiplication is the reciprocal. So that 5 times 1/5 gives you 1. 1 is the identity. The number times its inverse gives you the identity. Here, the matrix times its inverse gives you the identity matrix. Now, originally in class, when we did this, there's a note that I just erased right here. You can back up just a few seconds and see it. What we got was not 1001. Okay, we had a couple of wrong numbers in here because I got careless with a step. We fixed that, and now we have the correct inverse. So now we get 1001. That's the meaning of this note, but it's now irrelevant, so I'm going to get rid of it. I'm going to go off camera to do that, though.